Hello and welcome to the third video on trigonometric integrals, where we will handle integrals of the form. Let's say that you have something like sine of m times x cosine n times x dx, or integral of sine mx sine nx, or integral of cosine mx cosine nx. Now, to handle these types of integrals, we use the product to sum formulas from pre-calc. And those formulas look something like this. If you take sine of mx times cosine nx, you can always rewrite this as 1/2 times the quantity sine of m minus n x plus sine of m plus n x. If you take the sine of mx times the sine of nx, you can always rewrite this as 1/2 cosine m minus n x minus cosine m plus n x. And if you have cosine mx cosine nx, you can always rewrite this as 1/2 times the quantity cosine of m minus n x plus cosine m plus n x. So rather than try to do an integration by parts, we're going to use these formulas and rewrite them as sums and be able to integrate these very, very easily. So let's look at an example of this in action. So we'll go ahead and clear this. And let's say that we have the integral of sine of 3x cosine of 5x dx. We're going to rewrite this as 1/2 times the quantity of sine of 3 minus 5x plus the sine of 3 plus 5x dx. And this becomes 1/2 sine of negative 2x plus sine of 8x dx. And we can move the 1/2 on the outside. We can switch the order here for addition. So we have sine of 8x. The odd property enables me to move this negative outside, minus sine of 2x dx. And now I have fairly straightforward integrals to evaluate. Where we're going to use that formula where if you take the integral of the sine of ax dx, this is equal to the negative cosine of ax over a. So we're going to use this formula for these two guys here. And we have 1/2 times the quantity 1/8, negative 1/8, cosine 8x plus c1. Then we have minus 1/2 times negative 1/2 cosine 2x plus c2. And a little bit of multiplication here gives negative 1/16 cosine 8x plus c1 over 2 plus 1/4 cosine 2x minus c2 over 2. And again, we can go ahead and combine our constants of integration so that we have negative 1/16 cosine 8x plus 1/4 cosine 2x plus our arbitrary constant. So this is one example where you can use the product to sum formulas to perform the integration rather than try to do integration by parts twice. And this is a common substitution made when you have the products of sines and cosines. So let's look at another example. Let's say that we have the integral of cosine x cosine 4x dx. Okay, well, again, we're going to use that product to sum formula, and we're going to get 1/2 times the quantity of cosine of 1 minus 4x, and then we're going to get plus the cosine of 1 plus 4x dx. And then we get the integral 1/2. This is cosine negative 3x plus cosine 5x. And again, the even property of the cosine allows me to absorb the negative. So I'll go ahead and factor out the 1/2 cosine 3x plus cosine 5x dx. Now I can split this up into a sum of integrals. And when we do this, we now can go ahead and use our formula that when I have the integral of the cosine of ax, this is the same thing as 1 over a sine ax plus a constant. So we'll go ahead and use that formula, and we end up with 1/2 times 1/3 sine 3x plus constant, and plus 1/2 times 1/5 sine 5x plus another constant. And then we go through and do the arithmetic. 1/6 sine 3x plus c1 over 2 plus 1/10 sine 5x plus c2 over 2. Go ahead and combine our constants of integration. We have 1/6 sine 3x plus 1/10 sine 5x plus an arbitrary constant. And this is our result here. And this again is how you can do a product of sines and cosines. And again, this separates a product into a sum, which means we can separate the integral out and evaluate each piece of this integral rather than trying to do integration by parts. So thank you for your time and attention.